Hey everyone, it's Tuesday, it's 3 o'clock. That means it's Tech Tuesday. Today I'm going to be talking about distributed access architecture and flexible MAC architecture, what they mean, and how that's helping cable operators improve the service and the speeds and the reliability where they're delivering cable service without having to do a complete fiber deployment. Be right back. Thanks for joining me. Again, Rick Uzi here with Tech Tuesday. And today I'm going to be talking about DAA and FMA, two of the many acronyms in the cable world. FMA is newer as far as an acronym goes than DAA. So the reason for this is that cable operators, I just realized I need to turn on another light here. Hang on a second. That's much better. Okay. So the reason that cable operators need to do this is they are trying to get their reliability better and increase speeds as customer demand has increased. They've had to do a lot to try to get speeds to increase for those customers. This is especially with fiber being a competitor that quite often is coming in their areas, or even just something like 5G where they want to up the speed to, let's say, maybe increase speeds over what somebody now might be able to get through maybe a mid-band 5G offering like a T-Mobile or Verizon might be offering. So the point of that is to, again, increase speeds and then also reliability because, cable, unlike fiber, for example, is prone to RF issues and, those things getting out of alignment much more easily as you've got, corrosion and you can have cables get bent. Of course, that can happen in the fiber world where fiber gets bent. It can cause some degradation, but generally fiber is pretty good. Doesn't usually get bent, and usually unless it breaks, you're good on the fiber. I might get some dirt on the ends, but usually if you install it properly and everything, get it in the ground properly in the conduit or up on the poles, unless you've got some kind of a storm or something that comes through that knocks things out, fiber is pretty consistent. Whereas cable, just the elements over time, temperature, again, corrosion, squirrel chews on cable, water getting in there, cracks in cable, those kinds of things can cause real headaches for cable operators. Plus you've got that RF signal, so you don't really have this, you don't have a digital signal, you've got an analog signal, and then you're having to amplify that over time. So you've got all kinds of things that can crop up. So cable operators have been for years trying to improve the reliability of their plant, and a lot of that has had to do with putting fiber in their cable plant, starting out with analog fiber really back in the early mid 90s, I guess, analog fiber, the HFC or hybrid fiber coax kind of model. But they're trying to get away from the analog as much as they can and go to IP data kinds of transmission. And then again, getting fiber out in their plant as far as they can without having to rip out the last mile or so, because that's the really expensive part. If you're in let's say a brownfield area where you're already providing service, you don't want to, it's a lot more costly to go fiber to the home if you're delivering an HFC kind of service to somebody already versus, let's say, a greenfield area where maybe then the costs are closer because you're just going to be deploying new service and you're doing complete new construction versus ripping out your old plant. So they're trying to find out ways to do this or trying to implement ways to do this. And distributed access architecture is a great way to do that. And then FMA, flexible MAC architecture, kind of standardizes those things. So I was going to talk about those and do the best I can to kind of provide an overview of that, not go real deep because I can't go real deep. I can only kind of go, surface level on these things. But hopefully if this is something that's new to you, then this will help you understand some of these kinds of technologies. So we're looking here again titled DAA and FMA. So those are two acronyms: distributed access architecture and flexible MAC architecture. So what is DAA? So this is something that decentralizes the cable network. So typically you would have in a cable network, you've got your CMTS, your cable modem termination system, and that sits in the head end or in the hub. And then from there, you've got a distribution network, basically, again, using RF that goes, a combination of this analog fiber and coax cable that's going to go out to the customer. In between, you've got various actives and passives, your actives being things like amplifiers, your passives being, your things like taps and splitters, those kinds of things out in the field. And that's all delivered to the customer over this HFC network. So the point of DAA, distributed access architecture, is to remove as much of that RF and analog stuff, the RF signal and the analog kind of signal, and get to more digital fiber and go further out toward the customer, because then you've got the benefits of reduced maintenance, you've got a cleaner signal, those kinds of things. So we'll talk about that. So again, this moves certain functions that would normally be in the CMTS and in the head end into the field to, let's say, a fiber node. So instead of a full CMTS, you're going to strip out parts of that and put it out remotely closer to the customer. So the first thing that we saw with distributed access architecture was remote PHY, and that's removing kind of the physical layer, or the part that the coax plugs into is what moves out into the field. So it moves the physical layer functions out to the node. And that's done using what's called a remote PHY device, or RPDs. So that piece of the CMTS, so to speak, moves out into the field. So that does help you extend that architecture. And that was the first thing, that was the first standard that was developed, was the remote PHY standard. And it was, I think, easier to develop that standard, and it's easier for cable operators to deploy it. It was easier for the vendors to manufacture these devices because it wasn't a complete, let's say, remote CMTS kind of solution out in the field. It was just this physical piece that went out in the field. So that was the first thing that came around. And then remote MAC-PHY was something I think that was always considered as maybe the next step, or another step, or optional step. Remote MAC-PHY moves the MAC function out to the node. So it takes the MAC function of the CMTS, it puts that out there in addition to the physical kind of stuff. And that's done using what are called remote MAC devices, or RMDs. And really what that is like a mini CMTS. You're basically taking the CMTS functionality, instead of having this big piece of iron that you've got in your head end where you've got a bunch of customers connecting to that, you can then have these smaller RMDs, like a CMTS-like device, out in the field, connected back to the head end. And in the head end, basically, you've got servers and stuff that are doing the other kinds of operational support systems and some of your packet cable support stuff back in the head end. And then you've got your RMDs out on the edge, or close to the edge. So those are the two types, basically, of distributed access architecture. And again, remote PHY started first, but I think remote MAC-PHY is where a lot of the momentum is going to be moving forward, as the standards are getting more clear on that, especially with the FMA standard that I'm going to be talking about here. So I think remote MAC-PHY will be where folks are going, although it really does depend on what the situation is, because in a situation maybe where they've got plenty of power and room in their head end, and they've got plenty of headroom on their CMTS, maybe they just it's easier for them to put RMD or RPDs out in the field, these remote PHY devices. But if they're kind of constrained on power, space, or in certain situations where maybe they've got an MDU out there and they want to serve just a limited area, something like a remote MAC-PHY kind of deployment makes sense. But in a lot of cases, I think they're going to be, again, remote MAC-PHY is probably going to be taking over in a lot of the situations here, because it's a good way to go, because it moves everything out closer to the customer. So here's an example of, I saw this on a CommScope or some other place that gave CommScope credit, if I remember. So this is an example of your traditional kind of CMTS. They call it CCAP, Converged Cable Access Platform, I think, or ICAP in this case. So you've got your centralized architecture here. So this is basically CAA, or your centralized architecture, not DAA. And you've got your typical CMTS here. You've got your head-end optics, and then you've got your HFC network. So again, this is your analog fiber kind of signal here. You've got your HFC nodes. You've got you've got hybrid fiber coax with the coax cable delivering the service to the through actives like amplifiers, and then to some passives, again, like some taps and whatnot, out to the customers. This could be a tap and then a drop and then a customer's cable modem right here. So a lot of RF in this network, lots of places where things can go wrong. You've got you got to take time to sweep. Just realize I'm pointing the wrong place here. So you got to take time to sweep this plant. You've got to worry about customers calling in having problems, and you got to figure out where it's happening. So it's, again, it's RF signal. Is it happening somewhere out here? Is it closer to the home? And these issues are going to continue. These near home, in-home issues are going to continue on all of these if you're going to have coax in the plant. But at least on, in this case, you can eliminate a lot of the sweeping that goes on, let's say, between nodes as you are splitting these things out. So this is your traditional kind of cable plant. Then you've got remote PHY, and again, you've got your kind of your core, your MAC core here, CCAP MAC core. So this is still you're doing your CMTS functions here, but you've changed some things out here. You've got this fiber switching now. So you've got digital optics now, Ethernet. You've got this leaf and spine kind of network, converged interconnect network of routers, kind of routing, networking basically going on here. And then again, you've got your digital fiber, then you've got digital optics out here at the node, and you've got your remote PHY node. So a lot of times this remote PHY device can look just like you normally find in a node, except it's got the capabilities of remote PHY built in there. Then you've got, again, you can lose your amplifiers. I'm not sure if you have to be node +0, which would mean no amplifiers between the signal basically and the customer. I think it might have to be the case. So they're showing no actives here, no amplifiers. And you've got, again, any passives, and then you've got your customer here. So this is remote PHY, again, still having your CCAP MAC core here in the head end, but replacing all of this RF kind of signal and infrastructure here with the digital infrastructure and your converged interconnected network right here. Then you've got remote MAC-PHY. Again, now they're calling it a data center, I guess, because there's not really a CMTS here now. So you've got your data center with, again, your routing kind of system, your routers and switches with this leaf spine kind of network, and that's needed. This converged interconnect network is needed because you've got, unlike in this old infrastructure here, you've got you've got a lot more endpoints out there to communicate with, not just obviously the CPE, but you've got more, let's say, for example, RPDs out there, or remote MAC devices, RMDs out there that you got to communicate with. So they've got this leaf spine kind of interconnected network right there that they're talking about. And again, you've got the same thing here. So this looks very similar. You've got your digital optics over Ethernet. So again, the signal is going to be a lot cleaner here. And then out here, instead of just this remote PHY device, this RPD, you've got a RMD, or remote MAC-PHY device out in the node. So this again is like a little cable modem, a little CMTS. So this could be, again, look very similar to what you'd normally find in a fiber node. You've got that enclosure with all the electronics, but in this case, it's really a fully functioning CMTS that you have out sitting here at the edge. So again, you've got basically the CMTS closer to the customer. You've got more fiber between the data center here and the customer. So you've got less chances for things to go wrong, and you're delivering a cleaner, faster signal to the end user. So that's what we're looking at there. Then we've got, why is this better? So why DAA? So better end-of-line signal quality, like I say. So you've got, again, more fiber in the network. So your signal quality is going to be better. You're going to be able to do higher modulation rates because you've got digital fiber instead of this analog fiber, higher bit rates, those kinds of things. Spectral efficiency, so you can make use of the fiber that you have. You can squeeze more out of it by doing a lot, more wavelengths per fiber. Less head-end power and space and cooling. And that would be more so for a remote MAC-PHY because, again, you're taking the entire CMTS functionality out of the head end, so you're going to save even more space and cooling. But doing remote PHY helps as well, just not quite as much on that as far as head end power, space, and cooling. IP all the way to the node. So again, you're removing this analog signal, so you can deliver more kinds of services using IP that way. Higher modulations. So because of the fact that you've got more spectral efficiency, this fiber, you can do higher modulations, QAM modulations, so you can get faster speeds. This is going to, something like this is required if you're going to be doing something like DOCSIS 4.0, what they're calling the 10G initiative, where you're going to try to do, let's say, full duplex. You really need to be doing distributed access architecture, and I think definitely node +0, no amplifiers to be able to get the kinds of speeds. Maybe if you wanted to do symmetrical service, I don't think 1 gig symmetrical service is going to be really easy to do over DOCSIS, but you can certainly do symmetrical service at fairly high speeds this way. And of course, the 10G initiative is supposed to be about 10 gig symmetrical service. That's what the G stands for in 10G. It's not generation, it's 10G. But it remains to be seen how long that takes and whether that actually happens. And this is a stepping stone to a full fiber deployment. In fact, you could look at remote PHY as kind of being a stepping stone to remote MAC-PHY. So you can start out with just removing the physical layer out to the field, out into the node, and then kind of a stepping stone to removing the MAC and the physical layer, and then getting to remote MAC-PHY. Really, the next step would be, just fully doing a fiber deployment. So it makes it easier, I guess, if you're in a brownfield kind of situation where you're doing remote MAC-PHY, to take that next step of doing fiber to the home, because you're basically going most of the way there. Or let's say connecting up individual customers with fiber. So you can do that if you've got some important business customers. You kind of are already laying the groundwork for that. And then, of course, in greenfield opportunities, what we're seeing as we see cable operators edge out, especially now that we're seeing lots of money out there from the Infrastructure Act and ARPA and RDOF and all of that. We're seeing cable operators really do, if they're in greenfield, they're doing fiber. So they're not thinking about, even though I think if they're edging out their territory, unless they can leverage some of their traditional infrastructure that they have, they're generally doing fiber. So this is allowing them to do fiber to the home, or to really get used to doing that. And then in brownfield areas, they're going fiber as far as they can, again, without having to rip up that last mile. Flexible MAC architecture. So this is basically, this came about after DAA, because one of the issues with DAA and having remote PHY and then remote MAC-PHY was some compatibility issues. Can remote PHY work together with remote MAC-PHY, and what kind of interoperability we have between vendors. How do we handle all of the different things that we want to do on the network and make sure that everything's going to work together? So Cable Labs came out with a flexible MAC architecture specifications, or FMA, that's combining these two DAA options into this one spec, as well as additional things that they want to accomplish with this FMA. So it defines the separation of the management control and the data plane. So you're going to, when you're separating these things, this kind of defines on how all that's going to work together. So a couple of things that are in the FMA idea or concept is something called a MAC manager, and that contains the control planes. That's what integrates the different, what they call network elements, MAC network elements, or MAC NE, and that would be like your RPDs and your RMDs, your remote PHY devices, your remote MAC-PHY devices. It's got your converged internet connect network transport. It kind of defines that. Again, that's that, they call that SYN, another acronym. That's that network that I was talking about. That's kind of your routers and switches. That's basically what's going to be connecting your data center with your endpoints. So basically everything turns into IP switching at that point. And then you've got your MAC network elements, which I talked about right before that. So that's those are going to contain, so your RPDs, your RMDs are going to contain the control plane and the data plane that, again, normally would be in the CMTS. You've got your RPDs, RMDs, something called virtual core, physical core, remote MAC core. Can't try to remember what the remote MAC core. Oh yeah, remote MAC core would be like a fully functional CMTS that can also support RPDs on it. So you've got a remote MAC-PHY deployment out there that then has RPDs, or remote PHY devices, connected to that. In fact, I got a diagram of that right here. So this is looking at kind of a FMA overview that I got off of a Cable Labs document, I think off this FMA specification. So you can see here, they're showing the legacy, kind of the legacy deployment here, and then you've got your MAC manager, and you've got your packet cable aggregator. So for, let's say for voice, right here, this is your MMI, I can't remember what some of these things are. So you basically your MAC manager. This is the layer that kind of manages everything. Here's your P core and your V core. This is your SYN, your converged interconnect network. Basically your spine and leaf kind of network here. Your routers or V routers. This is your RMDs. So this would be a remote MAC-PHY device. This is a remote, what was that called? The remote Mac core. That's right, remote Mac core. So this is your RMC. So this is, again, kind of like a remote Mac device, remote Mac PHY device, but again, the ability to hang some RPDs off of that. So you've got here your RMD, your remote Mac PHY device with a cable modem connected to it. And you got your remote Mac core right here with some RPDs connected to it, one or more, and then your cable modems here. So again, you can see this is a very versatile network. So this gives cable operators lots of options on how they want to improve their network, because it's going to be a lot less expensive for them with all of the investment they have in their cable infrastructure, their HFC infrastructure, and their QAM-based infrastructure of delivering video, those kinds of things. It's going to be a lot less expensive for them to, again, go fiber to the home in areas where they already have that infrastructure. So this allows them to not spend as much, to be able to get much higher speeds to their end users, much better reliability than, let's say, going full fiber to the home in these areas. And then again, what you're seeing, I think probably all of them do at this point, certainly the major MSOs and even smaller ISPs now, if they are expanding into an area that they've not been before, especially if they're getting funding to do this, to help fund this, they are deploying fiber. And if they're deploying fiber, if they have the decision to make, am I going to do fiber, or am I going to do, I don't remember if there was another slide there. Am I going to do fiber, or am I going to do upgrade my cable plant, or am I going to build cable plant? Excuse me. If they're going to edge out their territory, let's say they're going to build a new territory, and they're deciding, am I going to do fiber, or am I going to do, continue with HFC in that area? Really, the costs are not that different, because a lot of it has to do with the actual construction and deployment of that, laying the cable, laying the fiber. So a lot of times they're going to make the decision to go in a greenfield area to go fiber. They've still got some things they need to think about, especially if they're doing video. They've got to do video maybe a different way. If they're going to do fiber, they've got to figure how they're going to authenticate the devices. They could do DPoE, DOCSIS provisioning on Ethernet, I think, where they can use their traditional DOCSIS provisioning system to be able to activate those devices versus, having to come up with a total new provisioning system for fiber. So there's different things they can do, but there's still challenges. But you're seeing cable operators make this, this kind of tailed off. DAA started to take off with remote PHY, and then it kind of tailed off a little bit. And I think since COVID and the need for more bandwidth, especially on the upstream, I think we saw a renewal of this idea that we need more capacity. We need to be able to do this better. We need to be able to handle the upstream better. And DAA is a way to do that without, again, having to rip out and go fiber everywhere. So we're seeing this gives cable operators a lot of flexibility, including doing fiber through this architecture as well. So they can do HFC, and then they can go fiber to some customers. They can go cable modem to other customers using this infrastructure. In fact, there's a spec out there, and I think they're already delivering the devices. Came out a couple of years ago called GAP, which is basically this generic housing that you can put different kinds of modules in depending on what you want to do. So you don't need to necessarily have buy a complete whole different housing for different types of things. You can have this generic housing and then put different modules in there if you want to do fiber, if you want to do 5G, if you want to do anything else. So lots going on in the cable industry. So this is how cable operators are right now looking at competing with fiber in their area if they don't want to do fiber themselves. So IFMA, it's standardized. It's the different disaggregation technologies that we're talking about here. Do we move out just the physical layer? Do we move out the MAC and the PHY? What about if we're doing fiber out there? Kind of standardize all this stuff together. Enables deployment of mixed technologies. So you can have RPDs and RMDs in the same network and everything acting and playing nicely together. Interoperability between vendors. So you can have different vendors that are all writing to the same standard, so if you're getting an RPD from one vendor and an RPD from another vendor and a RMD from a vendor, that they're all going to, again, play nice and talk together. And I think it's a step towards SDN, or software-defined network. So eventually, right now we're saying this kind of moved as like a data center now in the head end, where you've got basically routing and switching going on, and eventually, everything could be virtual, where you could have that sitting off somewhere. I don't know, maybe in Amazon somewhere, where you've got, that's basically what's controlling the network, and then you've got your endpoints out there that are doing the work of the cable network. So it's all moving in that direction, and what remains to be seen is how long cable operators do this. The last time I looked at reports on this, it seemed like there was still a good 20 years left in the I just saw my picture freeze there. That probably happened for you too. I just saw that. So there's still another 20 years or so as far as HFC, again, in these existing areas where cable operators are just not ready to rip everything out. So they're trying to do the best that they can to make the most and squeeze the most as they can out of that network. But it remains to be seen, again, with fiber competitors coming in and what that does as far as how quickly cable operators decide to do the rip and replace. That may be accelerated as competitors come in, as more, let's say, dollars come in from different programs. Although if a cable operator is already out there and they're already providing service well over 100 by 20, there should not be a competitor that comes in that's funded. But you still may see, a good example would be 5G, where it's not that expensive to, they're putting in towers everywhere to hit a particular area here or there with 5G service. So again, cable operators may want to accelerate their plans in some areas. So I think first thing we'll be seeing is they'll be getting as much funding as they can on their own to go deploy fiber in areas that are currently unserved or underserved. So we're seeing that with Charter. We're seeing that with Comcast. We're seeing that with lots of cable operators, MSOs, that are trying to get money to be able to do their own deployments of fiber in these areas that gets funded by the government in these areas that are a little bit more costly to do. So we'll be seeing that. And once a lot of that activity is done, then I think they're going to be picking particular areas where they say, it's not worth upgrading this to DAA. We're just going to pick off one at a time and just pull it out and put in fiber, or overbuild fiber where we are and then switch everybody over to that. So we'll be seeing that. I think it's going to be accelerated from what we were expecting, just let's say prior to COVID and prior to the Infrastructure Act and all of the money that's coming in. I think we'll see an acceleration of that, but it's still going to be many years. So these are ways that cable operators can leverage the plant that they have and continue to use that over time. Thanks for joining me. Hopefully this was helpful. I like, again, I can't go too deep, which is good for some people. They watch these things and they go, okay, well, that's really all I needed to understand is what do these acronyms mean and how does it kind of work together? So hopefully that was helpful for you. If so, give me a thumbs up on the video. If you're not subscribed, click the little subscribe button right there and click the bell and you will be notified when I'm live. And I'll be live tomorrow with broadband deployment news, as well as every other day of the week, other than Tuesdays. Next Tuesday, I will not be here for Tech Tuesday. I normally am, but next Tuesday, actually, I'm going to be participating in a Broadband Coalition mapping meeting that they do once a month. And one of the things that we're concerned about is the broadband maps and the broadband fabric. That right now the broadband maps are kind of being developed in a sense because the FCC has collected all the information that they've gotten so far from broadband operators on where they're offering service, what the maximum download and upload speeds that they're advertising in those areas, the latency, what type of service, those kinds of things. They've collected that information from broadband service providers for every location that broadband operator can serve. But there's concerns about accuracy of that broadband fabric that determine where every location was, and there's concerns about I did a survey and it turns out that a lot of operators were not real confident they were going to be able to finish this on time. The FCC, the last time I looked, was still accepting the information. So if you're an ISP and you haven't yet been able to do it, definitely get that done, because there was a deadline back on September 1st, but get that done as soon as you can, because it is known that there's issues with the fabric. But the challenge process has started where people are now challenging that information. And I heard something the other day where maybe the FCC said, maybe the maps won't come out in November. We were kind of hoping they would come out in November. I don't know. But anyway, I'll be participating in a meeting next week on that, just to see what the status of that is. And I'm going to present some of the information that I collected on from the survey from 41 different service providers and how they were progressing on their filing and some of the challenges that they had. In fact, I did a broadcast about that last Tuesday, I think it was. I think it was on Tech Tuesday last Tuesday. So look back for that if you're interested. And I'm going to, again, we'll look at that information. I'm also going to do a blog post on that in the next few days. So I'm going to go ahead and post that on our site. So you see there's equorum.com. On there you can find our blog, and I will post something on that survey on the broadband fabric here in a few days. Thanks for joining me, and I will see you tomorrow for Broadband Deployment News. Take care. Bye-bye.